the Moon and the Sun. Using the method of reverse engineering and with knowledge of electromagnetism, electromagnetic fields, gas ionization, fluid mechanics, dynamics, frequencies and oscillations, we ended up discovering something important for the starting point of true science research. The Moon is a phenomenon of ionization of the ether at a certain high layer due to concentrated cosmic energy minus, where it comes concentrated there. This energy, as it comes from the bottom up, is refracted at the ceiling of the field and then imprinted below on the Moon imprint layer, where it is imprinted concentratedly. In this way, the Moon works like the mirrored hologram of the Earth. The existence of the Sun is due to the same phenomenon, except that the Sun constitutes the other cosmic refraction, plus. Due to the source of the phenomenon, the Moon has the ability to capture the relief of Earth in live transmission, impression of a material field on the ether, with great detail, giving us the possibility to observe there the size of the Earth, to distinguish the continents and oceans, to observe the relief of the ocean floors, to get information about the subsurface, to find energy points and deepest ocean points, which also correspond to the stars and constellations, to find hidden distant or nearby continents, and generally to study geography, physics and cosmology from this point of view. The movement of the Sun and Moon led us to the cause of their creation. The phases of the Moon have revealed to us the Moon projection limits which the existence of the Sun places. We have seen that there is a direct connection between the phase of the Moon is in and how far ahead or behind it is from the Sun in the constellations in the spiral path. When we have a new moon, the Sun and the Moon appear in the same constellation. As the Moon is going to be full and is half, Sun and Moon are 3 constellations apart. At full moon we have 6 constellations difference, and when it is going to be empty and is half, 9 constellations difference. Continuous and studied observation of the face of the Moon has led us to the conclusion that the Moon is the hologramic cosmic concentrated reflection of the Earth, shaped like a lens which is formed at the end of the material field bordering the ether, at the boundary of the ionosphere with the ether. Determining the rotation of the Moon around its center for an observer during its course through each lunar day, and with knowledge of dynamics of motions and impressions, we divided the face of the Moon into axes, and in this way we can use it as a compass. Also, the above confirmation, and by experimental means, also proves the correctness of the concept. Studying the speed of the Sun and the Moon, we concluded that it is the new Moon that causes the eclipse of the Sun when they are at the same latitude. The conical refractions that create the Sun and the Moon when they are entangled shape create the phases of the Moon, while when they are opposite and not entangled, we have a full moon. When the refraction that causes the Sun is exactly opposite that of the Sun and at the same latitude, we also have a lunar eclipse. Each lunar day lasts 24 hours and 50 to 52 minutes, and during this time, the Moon makes a complete circle in the component of the circular motion in its total spiral motion. For this reason, every day the Moon lags 50 to 52 minutes behind the Sun. We have a new Moon every 29.6 days, while in a year we have 13 moons. The Prague astronomical clock and the Antikythera mechanism verify the model.
My reputation is too high to let somebody drag me with me.
Oceanographia, stars. Studying oceanography from the map of the Moon, we found that the points of the oceans characterized as super deep as well as other energy points of the Earth align with the constellations and generally the stars in the celestial electromagnetic dome. Essentially, there is an imprinting of these points in the etheric field above. This happens a layer above that where the Sun and Moon are created. The imprint here is simple, proportional, and not concentrated as in that of the Moon. So, in the electromagnetic dome, on this layer, we can see again the map of the Earth if we match each star with each energetic point that causes it. In this case, we see a part of the total map, almost half, on the entire celestial electromagnetic dome in the starprint layer. Celestial phenomena. By dissecting space and knowing the properties of the ionosphere, we explained shooting stars, comets, meteors, the northern lights, starbursts, and black holes. As we have in the homosphere the weather phenomena that benefit the water cycle, so we have in the heterosphere, specifically at its upper level in the ionosphere, the phenomena that benefit the cycle of noble gases and fumes. All the above phenomena are essentially burning and saturation of fumes at the level of the ionosphere. Depending on the height at which this happens, the size and composition of the fume cloud, and the type of saturation or combustions, meteorites, comets, star showers, black holes, exploding stars, etc. are created respectively. The northern lights is the electromagnetic imprint of the currents of the ionosphere because there, the ionization directly receives the energy from below from the magnetic north. The center and the big cycle. The center of the Moon is not the magnetic north. It is the center where the magnetic north moves with a radius around it. This is the so-called Great Circle, which makes one complete circle every 26,000 years. The existence of the Great Circle that magnetic north makes transforms the Earth as a living organism that ages but also regenerates. Planets. The word planet comes from the Greek word plani, which means apparent deception. The planets are not material bodies, nor they are where we see them. What we see and call planets, which have their own orbits and not like the stars of the dome which follow the rotation of the etheric field which surrounds us, are in essence impressions of fields containing one within the other, each one on its ceiling. These two fields together are contained within the field of Mars, which in turn is contained and rotates within the huge field of Jupiter. Jupiter, along with its energy field satellites, are included in the field of Saturn, which is in the field of Uranus. The divergent movement of the smaller fields within the larger fields causes their imprints to move on their own trajectory with each imprinting on the respective ceiling of their field. This is how a different observed complex motion is created for each field planet imprint. These movements can be seen in the geocentric model and in essence show how each smaller field behaves within the larger one that is located. The outer fields seem to have swallowed the movement of the inner ones, only that they also have their own movement. Sun's and Moon's altitude. By using the solar angles of incidence per latitude and per season, we can calculate the height at which the Sun is located. At the equinox, the Sun passes directly above the equator. The angle of incidence for the most meridian moment is 90 degrees. At the same time, for example, in the circle of Capricorn, which circle is 2,500 km from the equator, at a point with the same geographic height as this point of the equator that we said before, the angle of incidence is equal to 90 minus 30 equals 60 degrees. Thus, a right triangle is created, whose angles we know as well as the lower vertical side, which is equal to the distance of the two circles of latitude and, in our example, equal to 2,500 kilometers. Taking the tangent law, we can solve for the other vertical side for the triangle, which is the height of the Sun. We find this height 5,500 kilometers. Examining the shadowing caused by the Moon depending on the circle it makes leads us to conclude that if we express the frequency of its movement in the circles of latitude, it causes the same angles of incidence with the moonlight as those of the Sun passing through the corresponding circles. Thus we conclude that the Moon is also approximately at the same height as the Sun, slightly lower. Stars regions and black sun coil. The celestial electromagnetic dome, where the stars are captured, is divided into the inner region, where it is observed from northern places of the Earth, and the outer region, where it is observed clearly from far southern Earth's places. We don't see all the layer of the star's imprints because of the perspective of the horizon for how high they are. In the inner region, the stars move converged towards the north, while in the outer region they are diverged. This is because the outer region stars are outside the bounds of the lower cosmic ray circle, and so their paths appear to diverge due to the dynamics of the source's motion. Accordingly, as we know, the stars that are within the lower cosmic energy circle converge towards the north due to the geometry of the source dynamics. The moving source that causes the cosmic energy, working like a Tesla coil, depending on where the center of excitation is, creates different angles every moment, making the constellations rotate around the pole star at a certain speed. It also captures the Sun and the Moon in different positions so that we also have their movement with different relative speeds. These movements are described in the Antikythera mechanism. As the source moves spirally in n spirals, it creates every moment different conditions of incidence of the cosmic radiation from bottom to top. The diameter d of the spiral of the black sun has a certain length much smaller than the diameter of the Earth. If we consider that the stars are imprints of points on the Earth itself, we divide the Earth, and thus the stars, into two regions. In that which is within the diameter of the downward spiral movement of the black sun, and in that which is outside. The first captures stars converging towards the north, while the second diverges. World Maps by Plasma Moon. World Political Map. In this map, we can see all the countries. Pangea Selenographic Map. Physical Geodesic and Oceanic World Map. In this map, we can see the ocean surface, the deep hole crater, shallow water, trench, deep water, sun motion, moon motion, time zones, ground morphology, lakes, rivers, deserts, underground water, mountains, ice wall, vegetation forests and parks, islands, gulfs, Antarctic stations, kilometer scale. Physical world map. Plasma types. Electromagnetic world. We live in an electromagnetic world where at higher frequencies there are etheric fields, while at lower frequencies we have the material field, the Earth. The expression of electromagnetism is done by creating a field. The ether, like the noble gases of the ionosphere, have the ability to react to these fields, producing light due to ionization. These reactions are called plasma phenomena, and they exist everywhere around us, having a dynamic of motion and a periodicity. In this section, we will examine each plasma phenomenon separately to get a better understanding of the term plasma. Regions of space. As we have said in Book 3, space is divided into sublunar and superlunar regions. In the sublunar place, we have the four elements that make up the material field, lower frequencies. Earth and water, as denser, are in the center, while air and fire surround them. Thus we have the background with earth, land and water, while the atmosphere is divided into the homosphere, which refers to the element of air, where the water cycle also occurs, and the heterosphere above, which refers to the element of fire and where the cycle of fumes occurs. The superlunar place is ethereal, the fifth element of matter, which is apparently a fluid with a density less than hydrogen. The ether covers all the superlunar fields of high and even higher frequencies. When the ether of the nearby superlunar place or the noble gases and hydrogen of the sublunar place referred to, the element of fire, receives electromagnetism, then the molecules of the respective element react to the electromagnetism by emitting light. Each element of the ionosphere, like the ether, illuminates differently, creating phenomena such as the sun, daylight, the moon, and the stars of the electromagnetic dome. Depending on the height of the layer of each element, we have a different reaction to the cosmic electromagnetic field, which comes vertically from bottom to top and vice versa. Plasma phenomena. In essence, we call plasma the phenomenon of ionization of a compressed medium fluid due to electromagnetic field radiation. That is, the reaction of its molecules to electromagnetic radiation within a field at a specific pressure and temperature. The plasma phenomenon can be at different levels, resulting in the creation of layers of plasma types, depending on the medium and the height it is, in relation to the sublunar and superlunar place. Plasma sun, sun. The sun is a plasma phenomenon, a derivative of the positive refraction of cosmic electromagnetic energy where it is concentrated and imprinted, concentrated on the helio layer in the ionosphere that borders with the ethereal space. It happens in a semi-ethereal environment at around 5,500 kilometers. As we have seen, the cosmic energy that emerges from below is separated and refracted into positive and negative following internal reflection at the boundaries of the field and creates the sun and the moon. The Sun is created by electrically excited helium and hydrogen molecules or ether in the upper layers of the ionosphere at the boundary where it borders the ether. Due to the geometry of the source of cosmic energy and the dynamic of the movement of the electromagnetic field, the Sun, shaped like a lens, is created at a height of approximately 5,500 kilometers, having a diameter of approximately 51 kilometers, and moves spirally, creating day, night, and also the seasons. It is the pilot electromagnetic source which creates daylight in the lower layers of the atmosphere. The ionization in the element helium gives white-yellow light like the Sun itself, even having the same UV radiation values. The helium element is ionized where the positive plus component of the plus and minus refracted cosmic energy comes concentrated. The Sun is imprinting the ceiling of the field of the cosmic radiance concentrated. Plasma daylight, the light of the day. Daylight is created below the Sun-created layer in the ionosphere. There are noble volatile gases there, and because of them the daytime sky has these colors. As the Sun passes by, an electromagnetic field is applied to the masses of these gases in the ionosphere. Thus, high-energy electrons are produced which very quickly collide with neighboring molecules of the gas. Thus begins a sequence of chemical reactions. Daylight is a result of these reactions. It happens much slower than the Sun and the Moon, at 40 to 80 km altitude, in the material environment in the ionosphere, that is, the upper part layer of the atmosphere. This part has a relation with the element of fire as we saw in the book 3, and not with the element of air that the lower layers in Homosphere have. Every blue, red, yellow and their shades is light produced in the ionosphere due to the ionization of these gases. It is not scattered or refracted light. It is light called daylight plasma, and it begins and ends where reactions take place. The electrically excited molecules of the argon element and also of hydrogen fluoresce a blue color, giving this characteristic color to the sky. Neon is the source of every yellow, orange or red. It is more easily ionized with a minimal amount of electromagnetic energy and from a greater distance. For this reason, we see these colors first and last before sunrise and after sunset. Gases in the heterosphere and more specifically in the ionosphere, as we have seen, are separated into layers just like liquids in normal conditions with different densities. Each gas is in a layer and separated from the others. The separation is done according to the molecular weight and density of each element. These gases start from 40 to 80 kilometers and above, occupying the homosphere, the thermosphere and the ionosphere. There is helium, neon, argon, krypton, xenium, radon, monoatomic oxygen, methane, hydrogen. All of these gases are separated from the heavier air masses below. Far from the Sun in these layers, we have these gases inert and under very low pressures. When the Sun approaches, they are excited, ionized, creating plasma daylight, while when the Sun leaves, the reactions from ionization stop and the daylight disappears. It is a plasma effect similar to gas discharge lamps, but on a massive scale. Depending on the properties of each element, we have a different way of ionization. Ionized molecules produce heat, electromagnetism, radio waves, IR and UV radiation, light, and a magnetic field. In the homosphere below, the gases are mixed, and that is the layer where the weather phenomena and the water cycle occur. Water vapor in this layer gives a white tint to the color of the sky. Here there is nitrogen, oxygen, water vapor, and other gases. Water vapor and normal air are ionized at very low pressure, producing white light. Plasma moon, moon. Cosmic electromagnetic energy coming from below reflects into the inner upper part of the field and is refracted and printed further down that is being focused. The moon is created at the boundary of the ionosphere with the ether at a height of about 5,500 kilometers. Having a diameter of about 51 kilometers and shaped like a lens, it constitutes the negative refraction of cosmic energy. We have ionization of the element krypton or of the ether in that area, and the lower material field is imprinted, giving us the map of the Earth like an X-ray or the film negative, showing transparent the places where there is land while illuminating the places where there is water. It is a concentrated ionization of the ether of great precision, giving the essence of the background floor of the Earth. Plasma stars, stars. The stars are the individual ionization of the ethereal ceiling that separates the inner ethereal field from the outer fields, planets, moving stars. These ionizations occur due to the direct energy from the depths of the seas and from energy points of the Earth that comes from below upwards like the Moon, but a level higher. The map of the Earth is also depicted in the stars, with each star corresponding to a point on the Earth. In the night sky and on the stars, we can't see the whole map of the Earth like on the Moon, but a part of it, about half, and this happens because there, the capture is not in focus. On the Moon, we see the entire sky if we process its image with brightness and contrast. Constellations and stars are formed. But since the Moon is the imprint of the Earth, there is a correspondence between the parts of the Earth and the stars. Each energy point and each vast depth of the sea is imprinted as a star with a size corresponding to the intensity of the cosmic radiation emerging there. Every night, we see a piece of the total sky in the star print layer. Due to the different speed of this layer in relation to the Sun, we see different constellations every season. Plasma fields imprints planets. Mercury and Venus ethereal fields leave their imprint on the top of their field, showing what is included below: ethereal cosmic energy plus and minus. They are cosmic energy fields, and what we see are plasmatic imprints. Both of them, one field ceiling above, they shape Mars' ethereal field. What we see as Mars is a plasmatic imprint from Mercury and Venus together. Mars' field is included in Jupiter under certain circumstances. It is the red dot inside Jupiter, making a certain route inside it. What we see as Jupiter is a plasmatic imprint of what is included below on this field ceiling. Jupiter and its satellites are included in Saturn field. The ring of Kronos is the imprint of the satellites, like a photo with open aperture, and the inner part is Jupiter, but one field ceiling above. What we see as Kronos is the plasmatic imprint of all the lower fields that included. Saturn is included in the largest field of Uranus. What we see as Uranus is the plasmatic imprint on the top of this field ceiling of all the fields that included here. Tidal activity. In this unit, we will study tidal activity, high tide and low tide. Initially, we will find the places that show greater tidal activity than others. Then, we will examine the frequency and periodicity of the phenomenon, reaching the conclusions. The map below shows the tidal activity with the colors that describe the amplitude in meters in the oceanic and coastline areas. Tidal phenomenon in general. The sea currents and the water masses of the seas are affected by the electromagnetic field created by the Moon in relation to the position of the Sun. What happens is that we have the sea level rise for 6 hours and a few minutes, then we have the water stagnate for about 10 minutes, and then we have it recede for the same amount of time, with the stagnation remaining at the bottom for another about 10 minutes. In other words, we have an oscillation of the waters with comparable frequency and periodicity. In some observation points, the range of the phenomenon is larger and in others smaller. The tidal wave always comes from the east and goes west following the Moon. When this wave enters a bay with unequal openings and with a different orientation, a different speed of activity is observed, as a result of which we have phenomena of alternating water movement every 6 hours and a few minutes. The Moon affects the phenomenon in a geographical part more as it passes nearer the meridian of that part. The new Moon, as well as the full Moon, affect the phenomenon more, as well as the phases of the Moon that are nearby. On the day of the new moon and the full moon, we have the peak of the phenomenon. On the contrary, for the first quarter and the last quarter of the moon, as well as the days before and after them, the phenomenon becomes irregular, presenting a mess. In this case, we may have zero influence and the phenomenon may not be observed for a day or two. The periods of this disorder are observed twice in a lunar month and last for a period of 3 days. The first period of disorder includes the 7th, 8th, and 9th lunar days, while the second, the 22nd, 23rd, and 24th. After periods of disturbance, the waters do not acquire high tidal velocities, so when we have the so-called conjunctions, we have a greater range of tidal activity, while in quadrature, the currents caused are weaker, or even, if the barometric conditions and the configuration of the coasts and seabeds play a role, irregular. Tides and great depths. By studying the relief of the ocean depths, and particularly in the coastlines where they are marked on the map, we find that in the areas where a wide range of tidal activity is observed, there is a large sea gap or a deep trench or a super deep crater depth very close by in the sea that is near there. In contrast, we have a significantly lower range of tidal activity in marine areas with relatively shallow depths and on these surrounding coasts. In this way, we see that there is a relation between the depth of the oceans and the range of the tidal activity caused there and in the adjacent coastal areas. We notice that the great depths marked are responsible for the large range of tidal activity at these points, but also in the surrounding coastal areas. This phenomenon can be local or widespread. On beaches, where the sea is deep, the phenomenon is done with a large scale. The phenomenon of tides happens due to the properties of water that receives electromagnetism and frequencies. Water is a diamagnetic medium that accepts and affects electromagnetism and frequencies. The cosmic energy that comes from below penetrates the surface of the Earth, creates the moon and the sun at the boundaries of the ether with a material field. It affects more the great ocean depths due to a more direct effect and a closer distance with the source. Periodicity and alternative electromagnetic tidal zones. Coastal areas experience 2 low tides and 2 high tides every lunar day. As the moon is making its spiral orbit, 2 tidal waves are moving with it, creating high and low tides. The phases of the moon affect the maximum range of tidal activity, giving even greater values when the moon is full or new and minimum range on first and last quarter. The phases of the moon are also directly linked to the position of the moon and the sun on the constellations. 1 lunar day is 24 hours and 52 minutes, and in 1 lunar day the moon makes a full circle in the component of circle motion of the total spiral motion. High tides are created at the areas below and opposite the moon, and low tides at the other areas beside this, as we can see below. As the moon moves, it takes these tidal zones with it, and thus the phenomenon acquires a dynamic with a specific frequency and periodicity. We see that the surface of the Earth is divided into 4 moving quadrants, which alternatively mix the electromagnetic repulsion with the electromagnetic attraction between the line created by the moon and the source of cosmic radiation coming from below. Areas below the moon and opposite, relative to magnetic north, and in these quadrants experience electromagnetic repulsion, high tides and high water levels. Areas in adjacent quadrants experience electromagnetic pull, that is low tide and low water levels. Tidal electromagnetic behavior. So we can see that the existence of the moon, together with the cause that creates it, cosmic electromagnetic energy from below, with the spiral movement of the moon, is creating a sinusoidal field which affects the masses of water, either attracting them or repelling them with a specific frequency and periodicity. The fact that the phases of the Moon affect the magnitude of the phenomenon, as we said before, means that the position of the Sun also affects the phenomenon, and more precisely its position in relation to the Moon in the constellations. When we have conjunctions, the effect is intense, while when we have squares, the effect disappears. So we conclude that the cosmic electromagnetic frequency affecting the water masses is altered and maximized when the Moon and Sun align. The full phenomenon repeats itself every 12 hours and 25 minutes, while its frequency in one lunar day is equal to 2. This field, due to its sinusoidal form, creates local maxima and minima in the electromagnetic force exerted on the water masses, resulting in a positive or negative momentum in them, creating floods and ebbs respectively. Seawater masses located at great depths are more affected and provide more space for the phenomenon to spread. The vast depths of the oceans actually rest on the background of the Earth at their bottom, so in those places we have a great effect of this electromagnetic force. In this way, coastal areas that have a deep sea nearby have a large range of tidal activity, while coastal areas with shallow seas much less. This phenomenon is an electromagnetic phenomenon, since electromagnetic phenomena cause it, cosmic energy coming from below in the Moon. It is the cosmic breath of the Earth, where all the sea masses and also the coastal areas are affected, renewing the original conditions. Great depths influence. In this map, we see the huge depths of the seas that affect the nearby coastal areas, creating locally high tidal activity there. The tidal phenomenon seems complicated, but in fact, it is not difficult to understand. To fully understand and cover the phenomenon of tides, we will see some examples with maps. The Moon itself to identify the extreme depths where they are responsible for the large local ranges of activity as the Moon passes through these areas, being in various phases. At the same time, we will see what is happening in other distant or nearby areas, explaining the reason for the intensity of the phenomenon. In other words, we will do a review of the tidal zones and the electromagnetic field that the Moon itself is a result of. Example 1. In our first example, we have the Moon passing over Asia where it is seen in the image. As the Moon is a result of electromagnetism and ionization, carries with it the maximum of the electromagnetic field that creates it. Thus, as we saw before, a frequency and periodicity is created in the rate of change of the influence of this field on the sea masses. The Moon, in our example, is full, and just like when we have a new moon, it is the conditions that favor the phenomenon the most. If the Moon were on a course further south and closer to the latitude of the deep Indian Ocean, we would have an even stronger tidal effect because the oscillating vertical electromagnetic field would be closer to these depths. Here we see in the Indian Ocean the relief of the deep, which gives high tidal activity mainly on the coasts of northern Australia or Thailand Gulf, and less in the Bay of Bengal or West Australia, while some great depths north of New Zealand affect the coasts there. India from the east does not have big tidal ranges because the waters are relatively shallow, while to the west, due to the huge sea trench that extends from the center of the Indian Ocean to there, as well as two large crater holes on the seafloor there, it has large. Generally, the very white areas of the Moon map are huge depths in the ocean, so these points, when they are close to some coasts, affect them the most in the range of tidal activity. Example 2. Here in this example, we have the moon north of the equator over northwest Africa up from western Sahara. We again examine the phase of the full moon, which, as in the new moon, we have the greatest breadth and spread of the phenomenon. In the case of the full moon, the sun is opposite the moon in the constellations and we have an alignment. We also have an alignment at the new moon as the sun is in the same constellation as the sun. This seems to help the development of the phenomenon as we have the maximum activity values. As the moon moves from east to west, the arrow shows the tangent of its orbit at this point. It takes with it the tidal zones where they affect the water masses differently in places. The land is divided into 4 quadrants. The one below the moon and anti-diametrically opposite to magnetic north have high water levels and high tides, while the other 2 adjacent quadrants have low water levels and ebb tides. Here we see that the sea areas of the Atlantic Ocean that are on the European side of Alaska belongs at this particular time to the high tidal quadrants 1 and 3, while the Atlantic areas that are on the West American side have a low tide. It seems as if the super bottomless depths of the oceans act either as undersea springs or as whirlpool, changing their function every 6 hours and 12 minutes. The sun is the regulator of this function, while the alignment of the moon with the sun maximizes it. The phenomenon of tides is due to electromagnetic cosmic frequency oscillation that clearly affects the water of the seas. Example 3. In this example, we see the area further south of South America, namely the Southwest Atlantic and Southeast Pacific Oceans. The moon is in the new moon phase, where we also have the maximum influence, as well as the full moon, on the tidal phenomenon. Due to the phase of the moon, the sun is in the same constellation as the moon and they walk together in their separate spiral orbits. In our example, the sun is near the equator, while the new moon is further south, as we can see below. As the moon comes towards this region, it takes with it the tidal wave, which is the result of the oscillation of the vertical electromagnetic field affecting the water masses. As we saw in the quadrant that is under the moon and in the anti-diametric opposite, we have a high end in the oscillation that creates floods, while in the adjacent quadrants there is ebb. In other words, the tidal wave moves with the moon's movement and affects the depths more. In the South Atlantic, seeing the texture of the seabed from the map offered by the moon, we find that there are no great depths there, only shallow waters. On the contrary, on the South Pacific side, we have deep water and a large gap. Trans Canyon is located south of South America towards the eastern Pacific side. Thus we see that the eastern coasts of South America do not receive a large range of tidal wave, while in the south of South America we have a very large range of tidal activity, which certainly affects more southern Fuego and less southern Lacache. Example 4. In this example, the sun is between West Africa and Atlantis. The moon is at first quarter and is 90 degrees or 3 constellations behind the sun. Thus, it is located in the Indian Ocean approaching East Africa and its coasts. As we have seen, we have a case of quadrature, the sun with the moon, and thus the tide effect has a small or even zero range. The tidal zones are created again, but due to the minimal intensity of the electromagnetic field in the phases of the first quarter and the last quarter, it does not affect the waters except at the very extreme depths and there very little. So this pulsating electromagnetic field loses its intensity when we have the sun relative to the moon at an angle close to 90 or 270 degrees. In other words, we are talking about a pulsating electromagnetic field of varying intensity of a specific dynamic form with a specific frequency and period. Looking at the texture of the seabed on the coast of South Africa, we see shallow seas that do not favor the wide range of tides. On the contrary, in the Indian Ocean towards the Arabian Sea, we see some great depths there. On other lunar days, the phenomenon is intense. Example 5. In the last example, we will broadly see the phenomenon of tidal zones for a bigger part of the Earth. In this example, we have a 2-day moon, which phase is close to the new moon, and so we have quite a wide range of tidal activity. On the second lunar day, the moon trails the sun by a very small angle, and for an observer, the moon sets about an hour and 40 minutes later. In the places that are in the quadrant of the moon, but also on the opposite side, and especially in coastal areas that border on some great depth, we have a flood. The areas that are in the adjacent quadrants show a low tide, and again, in the same way, greater those that border the great depths. The coasts of all the coastal areas of the Pacific, in our example, have high tide, while the coasts of America towards the side of the Atlantic ebb. On the other side of the Atlantic, a high tide occurs in the east because it is opposite the moon at the time we are studying in our example. The coasts of the regions of Asia, Australia and Africa, where they are weighted by the Indian Ocean, have a low tide because they belong in an adjacent quadrant at this moment. This whole situation is constantly changing because these zones move with the moon, making a full rotation in 24 hours and about 15 minutes. Thus we have 2 floods and 2 ebbs in one lunar day. Surfaces, dimensions of continents and oceans. Every box is 1,000 kilometers high and 1,000 kilometers width. Every box has surface dimension 1 million square kilometers. Total Earth's surface dimension is 1,962.5 million square kilometers. Ocean surface dimension is 1,272.5 million square kilometers. Land surface dimension is 688 million square kilometers. Africa land. The surface dimension of Africa land is about 75 million square kilometers. The surface dimension of Eurasia land is about 52 million square kilometers, Europe 7 million square kilometers, Asia 45 million square kilometers. America land. The surface dimension of America land is about 25 million square kilometers, North America 12 million square kilometers, South America 13 million square kilometers. Australia land. The surface dimension of Australia land is about 14 million square kilometers. Lemuria land. The surface dimension of Lemuria land is about 28 million square kilometers. Atlantis land. The surface dimension of Atlantis land is about 25 million square kilometers. Terra Vista land. The surface dimension of Terra Vista land is about 434 million square kilometers. Hyperboreal land. The surface dimension of Hyperboreal land is about 6 million square kilometers. Atlantic Ocean. The surface dimension of Atlantic Ocean is estimated at approximately 556 million square kilometers. Pacific Ocean. The surface dimension of Pacific Ocean is estimated at around 124 million square kilometers. Indian Ocean. The surface dimension of Indian Ocean is estimated at 122 million square kilometers. African Ocean. The surface dimension of African Ocean is estimated at 92 million square kilometers. Kronos Ocean. The surface dimension of Kronos Ocean is estimated at 88 million square kilometers. South Terra Vista Ocean. South Terra Vista Ocean surface dimension is estimated at 104 million square kilometers. Australis Ocean. The surface dimension of Australis Ocean is estimated at 115 million square kilometers. Ranking. Lands in square kilometers. Terra Vista 434. Africa 75. Asia 45. Southern Islands 32. Lemuria 28. America 25. Atlantis 25. Australia 14. Europe 7. Hyperborea 6. Southern Islands are Terra Fuego Lakas, Galega, Sudarsana, New Zealand, Tasmania, and all the smaller southern islands. Oceans in million square kilometers. Atlantic, 556. Pacific, 124. Indian, 122. Australis, 115. South Terra Vista, 104. African, 92. Kronos, 88. Other seas, 72. Statistics. In the adjusted general pie, we see that the total percentage of land, sea, is approximately 34% and 66% respectively. Here we see the percentages of oceans that take up all the sea area, with the Atlantic Ocean having the largest area. Finally, here we see the percentages of continents in the total land area. Terra Vista has by far the largest percentage, while of the known continents, Africa is the largest. Moon and plants. As the moon gets bigger, the earth exhales. The energy goes from the soil up to the leaves. The juices rise and the growth of leaves and above ground shoots is favored. You should do all the actions with the plants that produce fruit above the ground as the moon grows. As the moon gets smaller, the earth inhales. The energy goes from the leaves down to the soil. The juices go mainly underground to the roots. The period when the moon is waning is a good time for pruning, fertilizing, watering, harvesting and weeding. The moon cycle lasts 29.6 days and is divided into 4 periods, quarters. One, new moon, first quarter, waxing crescent. 2. First quarter, full moon, waxing gibbous. 3. Full moon, last quarter, waning gibbous. 4. Last quarter, new moon, waning crescent. The plants are divided into 4 groups. Group 1, plants with root harvest. Group 2, leafy plants. Group 3, plants with seeds inside the fruit. Group 4, plants with seeds outside the fruit. Each group has been connected for each period, quarter of the moon cycle. The new moon is a good time to plant plants with outdoor seeds that produce fruit above ground. The cosmic electromagnetic field that causes the moon to exist causes plant juices to rise up and seeds to germinate and grow. The period of ever-increasing lunar brightness that follows also helps. Leafy vegetables and vegetables with external seeds like spinach, cabbage, cauliflower, broccoli, etc. push up the vegetable juice. The seeds will germinate faster and gradually, as the moon grows, it will encourage seedling growth. The first quarter favors planting vegetables with indoor seeds. For example, beans, peas, tomatoes, peppers, eggplants. In this phase, The moon is half and continues to grow larger every subsequent lunar day until it reaches the full moon. Leafy plants are most favored in this period. The full moon favors the sowing of vegetables grown for their underground part, root fruits, bulbs, tubers, sarcorizae, for example carrots, beets, onions, potatoes. After the full moon phase, the moon begins to get smaller and the electromagnetic cosmic energy gradually decreases, while we have more and more moisture near the Earth's surface. As the moon wanes from the full moon phase onwards, the influence of cosmic energy is focused on the roots of the plants. The last quarter, and until the new moon, is a fallow period, ideal for composting and clearing weeds. In this phase, we have reduced electromagnetic energy and reduced night light. It's fallow season. The moon makes one cycle through the constellations in about 28 days. Each constellation from the 12 constellations covers an angle of 30 degrees. If in 28 the moon covers the whole cycle of the constellations, making a 360-degree course in it, then we calculate that the moon stays 2.3 days in one constellation. Here we see which work on the plants will yield the best in each period of time when the moon is in any constellation. Aries, barren and dry, insect control, plowing, pruning, weeding and harvesting. Pruning while the moon is in Aries will help discourage the growth of nuisance plants and weeds. Taurus, productive and fluid, a good time to sow seeds. Also a good time to prune plants to control their growth. When the moon is on Taurus, is productive for planting root crops, especially when durability is important. Gemini, barren and dry, insect control, plowing and weeding. Harvest crops during this for long-term storage. Melon seeds fit this position. Cancer, very fertile and moist. It is one of the most fertile times for sowing and transplanting plants. Prune plants to encourage healthy new growth. Good time for fertilizer, irrigation and water the plants. Leo, very barren and dry. Garden chores that can be done when the moon is in Leo include weed destruction, plowing, pruning and weeding. Virgo, barren and wet. Prune trees, shrubs and herbs during this time to help them in shape. Libra, semi-fertile and moist, and a good time to plant flowers, vines and herbs. Also a good sign to prune the plants in order to control their growth and maintain their shape. Planting and sowing special flowers and grain crops. Scorpio, very fertile and moist, one of the most fertile times for sowing and transplanting plants. Best time to plant hardy plants and vines. It is also a good sign to apply fertilizers for the plants. Sagittarius, barren and dry. Insect control, plowing, pruning and weeding. Good time for harvesting and cultivating the soil. Pruning while the moon is in Sagittarius will help discourage the growth of nuisance plants. Capricorn, productive and dry. Good time for planting potatoes and other root crops and encouraging strong, hardy growth. Good for pruning to promote healing and for applying organic fertilizer. Aquarius, barren and dry. Aquarius is a good for plowing and weeding. Harvesting crops during this moon helps in long-term storage. Pisces, very productive and moist. One of the most fertile times for sowing and transplanting plants. This is another sign that favors crop fertilization, especially good for root development and irrigation. In addition to the position in constellations and the phase of the moon, it is appropriate to examine its position in relation with the planets. You can try to do your farm work on favorable days and times based on nature's vibes. Fish activity on lunar days. On the horizontal axis, we see the lunar days of a lunar month. On the vertical axis, the degree of fish activity with a maximum of 10. As we saw in the tides chapter, the moon along with the sun are created as a result of electromagnetic ether ionization within a spiraling, vertically moving electromagnetic field. The position of the moon as well as the sun are of particular importance in the phenomenon of tides, creating repulsive or attractive electromagnetic forces of specific frequencies on the water masses perpendicular to their position, making the great depths of the seas act either as springs, either as puffs with specific periodicity. Let's not forget that water is a diamagnetic material that accepts electromagnetism and frequencies and is affected by them. Every 24 hours and 52 minutes, we have the moon in the center of the sky. The most intense observation of the phenomenon of the flood occurs at this moment, but also during the antidiametrical with respect to the magnetic north passage of the moon, 12 hours and 26 minutes after the passage from the center of the observation sky. The most intense moment of observation of low tide is 6 hours and 13 minutes after and before the passage of the moon from the center of the sky from the observation point. This is how the tidal zones are created, which rotate in relation to magnetic north. The position of the sun in relation to the moon in the constellations affect the intensity of the phenomenon, while simultaneously creating the phases of the moon. In some phases we have a strong phenomenon with standard periodicity, such as in the maximum moon and the new moon. In some others we have a reduction of the phenomenon and confused waters, as in the phase of the first and last quarter and the lunar days close to these phases. These periods are called periods of disorder, where the waters do not have regular flows. All this is a natural consequence of affecting the activity of fish and animals in general. At moonrise and moonset, but also when the moon is in the center of the sky, fish move a lot and look for food at those times. Also, when the waters are down, there is not much kinetic activity, while when the waters are up, there is a big activity. When we have low barometric pressure, the fish are in a more relaxed state, while high pressure makes them more lively and active. Remember that the barometric pressure is the pressure exerted by the ionosphere on the homosphere. Its value changes, as in the ionosphere we have currents of noble gases, which are created as clouds or fumes from the surface of the earth, enter from below upwards, piercing these layers, changing the pressure and temperature conditions there. The phases of the moon greatly affect the activity of fishes, making them to have a behavior dependent on lunar days, as shown in the diagram beside. The motion of the stars. The electromagnetic dome in which the stars are imprinted, as we explained in the plasma imprint chapter, rotate around us centered on the pole star. But at what angular speed is it rotating? The Sun, from what we saw in Book 3 in detail in the chapter where we analyze its movement, makes a spiral movement. The angular velocity of rotation that concerns us here has to do with a component of its circular motion. Within 24 hours, it makes a complete rotation. The Moon has a smaller angular velocity as it lags behind the Sun by about 52 minutes each day, making one complete circle in 24 hours and 52 minutes, thus defining the lunar day, where 29 lunar days make a lunar month. That is why every day the Moon lags behind the Sun by approximately 12.4 degrees in terms of their rotation around magnetic north. The Moon is tied to the Sun, and in which constellation it is depends on its position in relation to the Sun, which fact also defines its phases. To return to the dome of stars and constellations, observing their movement, it is apparently similar to the Moon's and the Sun's one. The stars come from the east and live towards to the west, tracing a circular path centered on Polaris that is up from the magnetic north with a certain angular velocity similar to that of the Moon or the Sun. The Sun passes, or best aligns, within a year of all the constellations in the dates from the solar calendar as described by the zodiac circle. Next year, the Sun will be on the same date, exactly the same point in the zodiac cycle of the constellations, and the one-year loop is completed. If we consider the relative speed of the Sun in relation with this of the electromagnetic dome where the stars are captured, we can develop the following rationale. In 365.25 solar days, the electromagnetic dome with the stars lags behind the Sun by 360 degrees. In one solar day, we find that it lags behind the Sun by 0.98 degrees. If we consider that for 24 hours equals 1,440 minutes correspond to 360 degrees, then we find that 0.98 degrees corresponds to 3.94 minutes. Summarizing, we calculate the constant angular velocity of rotation with center the Polaris and the magnetic north of all the above phenomena in relation to the fixed and motionless Earth. Sun angular speed. The Sun rotates at a constant angular velocity of 360 degrees per day equals 15 degrees per hour, or else the Sun makes a full circle in 24 hours, as we know. Moon angular speed. The Moon rotates 360 minus 12.4 equals 347 degrees per day equals 14.46 degrees per hour, or else the Moon makes a full circle in 24 hours and 52 minutes. Stars angular speed. The dome of stars and constellations rotates 360 minus 0.98 equals 359.0144 degrees per day equals 14.959 degrees per hour, or else the stars and the constellations make a full circle in 24 hours and 3.94 minutes. Because of these different speeds, the Sun passes through all the constellations within a year, while the Moon, due to its individual motion in relation with the Sun, passes through them in a lunar month. Also, because of this fact, we see different stars on winter nights compared to summer nights. It is because the Sun, which carries the plasma of daylight with it, is in an antidiametrical constellation in the winter in relation with the summer. So at night, that we see the rest of the sky, that is not day, we see the other side of the electromagnetic dome that the stars and constellations present. Angular speed of sun. Here we see the so-called sun trail seeing a piece of the sun's course here specifically as it rises. This path is spiral as we saw in Book 3, examining the analemma. The circular component of the spiral motion is observed here. The angular speed of the sun is equal to the duration of one day, 24 hours. In other words, the sun makes one complete rotation around magnetic north every 24 hours, no matter what latitude it is at. So we're talking about partially different instantaneous speeds, but a constant angular speed of rotation. Angular speed of sun, A sun equals 360 degrees per day. We measure time with reference to this constant motion of the sun, thus determining the days of the year and the dates according to the latitude and the direction of the component of the harmonic oscillation of the total spiral motion made by the sun. Angular speed of moon. Here we have a moon trail at a moonrise, seeing a bit of its spiraling motion. The moon has a constant angular velocity of rotation lower than that of the sun, so every day it lags behind the sun by 12.4 degrees or about 52 minutes. And here we are talking about different individual measures and vectors of speed, but the angular speed of rotation remains constant. Angular speed of moon. A moon equals 360 minus 12.4 equals 347.6 degrees per day. By delaying the moon each day in relation to the sun, it lags behind of the constellations and the phases are created. Stars' angular speed. The stars and the electromagnetic ethereal dome also revolve at a constant angular velocity around the pole star. And here also we have different measures and vectors of the individual velocities of the different stars according to how near they are to the pole star, which remains stationary since it is the center of rotation and is always in a fixed point. On the other hand, stars further away from the pole star run at a higher linear velocity. However, the angular velocity of rotation remains constant. Angular velocity of stars and constellations. A stars equals 360 minus 0.98 equals 359.0144 degrees per day. Due to this speed, which is slightly less than that of the sun, we have the sun aligning with a different constellation every month, while in exactly 1 year, the sun returns and aligns with a constellation that was aligned a year ago. The moon has to do with the sun, and its phases are inextricably linked with the distance in constellations from the sun, changing all 12 constellations within a lunar month in about 29 days. Southern stars. The very southern stars appear to diverge from the north rather than converge like those further north. The stars are the imprints of Earth's energy points in the etheric space on the ceiling of our electromagnetic field. This is because below is what creates all of this cosmic electromagnetic frequency field, that the material part being the lowest one. This cosmic electromagnetic energy source, also called the black sun moves below and also rotates in a maximum and minimum radius, each time having a different angle of incidence from bottom to top. The surface of the Earth is larger than the radius of rotation of the black sun, so we have some areas of the Earth inside this circle and some outside. However, energy points exist all over the Earth. Thus, the imprints of energy points within the radius of the black sun appear to converge to the north, while the imprints of those outside the radius diverge due to dynamics and geometry. Night visible sky. We see that the sun, the moon and the stars are moving with different angular velocity, and the relative velocities make us observe all these alternations that define three moving layers. In the night sky, we necessarily see the rest of the electromagnetic dome that is not day. The stars in the night sky are changing position for a little every night, until in a year, at the same time, they will be exactly as it was a year ago. We will see that the sky looks like every first of every month at 12 o'clock in the midnight exactly, for months in a row. There is a slight movement of the stars each month due to the different and slightly greater angular velocity of the sun relative to the stars. So every day, for the same time, in the same place, the visible sky is a little different, something we observe in the following video. We observe that the relative angular velocity of the star canopy relative to the angular velocity of the sun's rotation creates repeated alignment conditions every year at the same time. An observed slight deviation created the leap years where they repeat every 4 years, having one day more, 366 days, and thus we would say that the total deviation of 4 years is equalized by the addition of this day. Planets' motion in the constellation circle. The so-called planets, when not visible at night, are on the side of the electromagnetic dome where the sun is and creates the day. In this video, we see the analemma of these etheric imprints, the planets during 14 solar calendar months in relation to the sun. We achieve this by taking a picture every day at the same time. We notice that Mercury and Venus always follow the sun in the constellations and always appear close. Mars, Jupiter and Saturn appear in all the constellations, tracing a geocentric course of complex spiral motion. Moon. The Moon, as we have seen, makes a complete revolution in the constellations within a lunar month, within approximately 29 solar days. Mercury. Mercury revolves around the Sun following it through the constellations with an oscillation around it in a small radius. It appears only in the constellation in which the Sun is located and in its neighbors. It performs a complex spiral motion and does not revolve around the constellations but around the Sun. There are periods when Mercury is retrograde, that is, every day it goes against the constellations. In one solar year, it rotates 4.14 times around the Sun while making a complete rotation in 88 days. It is the one satellite of the Sun phenomenon and has phases like the Moon. Venus. Venus revolves around the Sun, following it in constellations with one oscillation around it over a large radius. There are periods when Venus is retrograde, that is, every day goes against the constellations. In a solar year, it rotates 1.536 times around the Sun while making a complete revolution in 224.7 days. It is the other satellite of the Sun and has phases like the Moon. Mars. Mars follows the course of the constellations and behaves geocentrically, making a complex spiral movement. Its rotation speed is less than that of the constellations. In one solar year, it makes 0.5319 revolutions of the constellations and thus makes one full revolution of the constellations in 696.98 solar days. Its two satellites move in opposite directions. Jupiter. Jupiter moves almost along with the constellations in a geocentric course in a complex spiral motion. Its path through the constellations repeats every 4,334 days, since its rotation speed is almost equal to that of the constellations. Thus, in one solar year, Jupiter makes 0.0349 revolutions in the constellations. Its four satellites move in the same direction. Saturn. Saturn follows the course of the constellations, making a complex spiral motion while behaving geocentrically. Its speed is even closer to that of the constellations, so that it makes a complete circle through the constellations in 10,822 solar days. Consequently, in one solar year, it makes 0.0349 rotations through the constellations. The Great One Circle. The position of magnetic north changes and makes a complete cycle within 26,000 years. This is how the 12 cosmic ages are created, each of which lasts 2,166.7 years. Thus, we have the Epoch of Pieces. Epoch of Aquarius. Epoch of Capricorn. Epoch of Sagittarius. Epoch of Scorpio. Epoch of Libra. Epoch of Virgo. Epoch of Leo. Epoch of Cancer. Epoch of Gemini. Epoch of Taurus. Epoch of Aries. In every season we have the movement of the magnetic north and the climatic zones. Thus, for each season we have another part of the Earth node with a different Arctic zone. Correspondingly, we also have a movement of the equinox. Thus, there is aging, but also regeneration of all regions, seas and lands. The center of the big circle, maybe it will also make another bigger circle in a bigger unknown, making the whole movement of the magnetic north spiral. Electromagnetic cosmic spectrum and frequencies. In this section, we will break down all about frequencies and the electromagnetic cosmic frequency spectrum, looking at the physical quantities and separating the spectrum into individual categories. In this way, we will come closer to the cosmological understanding. Humans can hear a small spectrum of frequencies where it belongs to the generally low frequencies, while they can see an equally small spectrum where it belongs to the high frequencies. Frequencies can be transformed, transmitted, decoded, and stored in diamagnetic materials, solid, liquid, and gas, as long as they are electromagnetic in nature. Our world, nature, is permeated by almost every frequency, from visible light to very high frequency radioactivity. We have these types of frequencies: TV and radio frequencies, visible light, radioactive ionizing radiations, cosmic radiation. By the term electromagnetic radiation, we mean the transfer of energy in the form of an electromagnetic wave. By electromagnetic wave, we mean the local and temporal variation of the electric and magnetic fields. An electromagnetic wave is characterized by three physical quantities: the wavelength lambda, which is equal to the distance between two successive peaks of the wave and has units of length; the frequency of wave n, which expresses the number of repetitions of the wave per unit of time; Its measurement units are hertz. 1 hertz equals 1 cycle per second. It is related to the wavelength and the propagation speed of the wave with the relation U equals lambda ni. The electromagnetic spectrum is a continuous spectrum. In figure below, all the electromagnetic radiation known to date is presented. This consists of gamma rays, which have the highest frequency energy, X-rays, ultraviolet, the human visible spectrum, infrared, microwaves and radio waves. Categories. The electromagnetic spectrum can be divided into two large categories depending on the energy carried by each wave with its frequencies: ionizing and non-ionizing radiations. Non-ionizing radiations that do not have the energy to cause ionization. We meet these widely in our everyday life. Ionizing radiation, such as gamma rays and X-rays, are rays capable of causing ionization of matter. They have extensive use for medical purposes in X-rays and 3D imaging, airport screening, and many other uses. As we will see, gamma and cosmic rays create the sun, while X-rays create the moon by ether ionization. The origin of electromagnetic radiation is divided into two categories: natural sources and artificial sources. In natural sources, we can classify cosmic radiation that comes from below, creating the electromagnetic field that we are inside. Various birds and fish, thanks to their internal organs, can perceive this cosmic electromagnetic field and act as small compasses so they know where to head during periods of migration to other continents. Another natural source of electromagnetic waves is weather phenomena. Electrical discharges that occur in lightning storms create strong magnetic field in their vicinity. Our daily life is full of artificial sources of electromagnetic radiation. For example, all household electrical appliances, computer, mobile phone, TV, etc., which are included in the low ELF frequencies. Also, other artificial sources are various types of antennas for telecommunication purposes, radio television stations, and radars on military bases. As you can see, in the age we live in, electromagnetic radiation is constantly in front of us. With every step we take, our body is bombarded with different frequencies. We cannot see and hear all this radiation because our eyes can only detect a small spectrum, while our ears another spectrum also small. Convert, transfer, save. The conversion of audio frequencies into radio waves through electromagnetism and a transmitter allows the receiver with the corresponding electromagnetic decoder receiver to receive the radio waves and convert them back into sound waves and through the speakers to listen. The mode of operation of the television, the telephone, and the internet is similar. So we see that all of this is based on the fact that frequencies can be transformed, propagated or stored, decoded and transformed back into their original form. What is needed are the corresponding electromagnetic decoders and transformers. After all this study of the electromagnetic spectrum and all the individual smaller spectrums with similar properties, we have reached the point of seeing and understanding better what the ionizing frequencies cause. In cassette technology, sound frequencies are converted into a pulsating electrical current which is recorded through the cassette head onto the magnetic tape of the cassette. In this way, we have the storage of sound frequencies, and with the analog decoder, where the cassette player itself is, we can listen to the recorded sounds from the magnetic tape. The fact of frequency storage finds application in Internet technology as through high-frequency waves and similar transmitters, receivers, decoders, there is access to a huge layer of the ionosphere where it is ionized, providing storage space and fast communication with short system feedback times to the decoders. Thus, as there are solid and liquid diamagnetic materials, so there are corresponding gases that are susceptible to react to electromagnetism. As we have seen in previous issues, the ionosphere contains the noble gases, monoatomic oxygen and hydrogen. These gases are all diamagnetic and so can store very high ionizing frequencies. The entire spectrum of cosmic electromagnetic frequencies coming from below to above. The total spectrum reaches the ceiling of the electromagnetic field and is reflected downwards, having been refracted. The spectrum of X-rays from the total spectrum of cosmic frequencies, as it has been separated from other spectra due to the cosmic prismatic refraction of radiation, is now concentrated and is imprinted at the boundaries of the ionosphere with the etheric field, imprinting the base of the Earth where it penetrated vertically. Cosmic energy emanates from below black sun, creating an electromagnetic field. The cosmic energy contains all frequencies from the entire electromagnetic spectrum. Let us recall here the refraction of white light in the spectrum of optical frequencies, where it allows us to see colors with the analog decoder, our eyes. It is a transformation of the cosmic radiation into a field, the field of vision. In the same way, we have the X-ray spectrum image of the total cosmic energy coming from below at the level of the ionosphere, a phenomenon that creates our familiar moon, making it have the property of an X-ray of the base of the Earth. So the spectrum of very high ionizing frequencies, X, gamma and cosmic rays, as they bounce upwards, penetrate the surface of the Earth, are formed focused, and in the same way that we have the prismatic refraction of white light in colors, we have the refraction of ionizing frequencies and cosmic radiation in gamma rays and X-rays, creating the Sun and the Moon respectively. It is again a conversion of frequencies, whereby converting them into visible spectrum of frequencies, we are given the possibility to see the highest frequencies of cosmic energy in the Sun, and in the Moon, the X-ray of the Earth. The Moon is the concentrated focused imprint of the spectrum of X-rays of high frequencies from the total cosmic electromagnetic spectrum of frequencies. Ether and the gases of ionosphere accept and react to electricity by ionization. The entire spectrum of cosmic electromagnetic frequencies coming from below to above. The total spectrum reaches the ceiling of the electromagnetic field and is reflected downwards, having been refracted. The refracted spectrum of gamma and cosmic rays from the total spectrum of cosmic frequencies concentrated is imprinted at the boundaries of the ionosphere with the etheric field imprinting the cosmic energy shaping the Sun. The Sun is the concentrated focused imprint of the spectrum of gamma and cosmic rays of high frequencies from the total cosmic electromagnetic spectrum of frequencies. Ether and the gases of ionosphere accept and react to electricity by ionization. All the stars that move in the electromagnetic field, as well as the planetary stars, are ionization phenomena of the corresponding etheric field and occur in the corresponding etheric layer. What causes all this? The source of excitation of all this cosmic electromagnetic field. The black sun is a multi-layered and multiform source, creating all these layers of fields.